Hello, this is a problem similar to our homework problem. It says here that we have a list of ages in years of randomly selected race car drivers, and they want us to use a 0.05 significance level to test the claim that the mean age of all race car drivers is greater than 30 years old. So here's our list, and before we get to the list, let's set up our null and alternative hypothesis. So first of all, the claim says that the mean age is greater than, so the mean is given by mu, and that's bigger than 30. And so the opposite of this would be saying that mu is less than or equal to 30. And this contains a condition of equality, and the claim does not. So that means our null hypothesis would be the condition of equality, and our alternative hypothesis would be the claim. So that's our statement. We want a 0.05 significance level, and we want to first of all establish the fact that our sigma is unknown, and that means that we're going to need to use the t-test. We're going to use a t-distribution, and we'll use a t-test for this. So the t-test on a calculator allows us to input this information, the data set, into our calculator, and then have the calculator figure out the rest of our statistics. So normally we would need to find some values for t and compare it to the proposed standard deviation or proposed mean, and then we're going to use the sample mean and the standard deviation and the sample size. So instead of doing that, we will use our calculator and the data. Go to our calculator and make sure your data is inputted. I've already inputted the data on my calculator. It's in list 1, and I'm going to go ahead and go to stat and go to test, and we'll use a t-test. So I have a choice of either doing a statistics list, which I don't know right now, but I do have the data in my calculator, so I'll select the data option. My mu sub 0 is our null hypothesis. That's going to be 30. My list is in L1, and the frequency is going to be 1. And so we look for the alternative hypothesis, and the alternative hypothesis is a greater than sign, which means this is going to be a right tail test. We go to calculate, and then it gives us a bunch of things. So let's take a look at the last 3 components or values here. First of all, we get x bar is equal to 33.6. We got the standard deviation is the sample standard deviation is 7.6699, so let's call that 7.7, and our n is equal to 15. Okay, so that's obtained from the t-test, but more importantly what we want are the test statistics. So our test statistic is going to be a t-test statistic, and that has a value of 1.817, and our p-value, we'll call it PV, is 0.045. Okay, now compare this to alpha. It looks like this is less. So we're going to say since the p-value is less than alpha, that is 0.045 is less than 0.05. We reject the null hypothesis. So we reject the null hypothesis, and now we write our conclusion. we look at our claim. Our claim does not contain a condition of equality, and we rejected the null hypothesis. And so we'll come to our conclusion by saying that we actually support the claim. So the sample data support the claim, that, and then we just see word for word, write down the claim that the mean age of all race car drivers is greater than 30 years. Okay, so that's our conclusion, and I hope that helps.